In fact, it's just the questions you see on that page. But yesterday we talked about the parameters h and k and what they do to an original function. But we expressed it in terms of f of, and we haven't really talked about what that means. What does that mean, f of x minus h plus k? And that's what we're going to delve into today. So these are just further examples dealing with horizontal and vertical translations and the parameters and the roles that the parameters play. Remember, the word parameter is a word we use as a label for a number in an equation that defines in some way the equation. And just to back up for a second before we even get to example 1, when you look at something like y equals 3x squared plus 2x minus 8, that number 3 is a parameter. That number 2 is a parameter. That number negative 8 is a parameter. We often write these quadratic functions as ax squared plus bx plus c. And as we delve deeper and deeper into the course, you need to appreciate that the things I'm about to highlight in yellow are what we call variables. They're things that you put different numbers in for x and get a resulting number for y. However, those are variables. However, these are parameters. For those of you that just finished Physics 30 with me, it's like saying when we do graphical analysis, we have variables and then we have constants. Okay? It's like that. It's not quite the same. So parameters are numbers typically that define the equation. And I want to keep using this word parameter because it's going to be helpful, hopefully, in solving some problems. So the first example says we want to write the function, the new function, after the transformation given, and we want to write it in the form y minus k equals f of x minus h. And again, I hope you can appreciate that that is the same as writing this. And at first glance, this question is not any different than what we learned yesterday, but it is different. It's significantly different. And my goal is to teach you the meaning of the function notation. So if I have this function, y equals 1 over x, and I translate it 4 units up and 3 units to the left, what's the equation of the function? Well, you should know, and we're not writing anything yet. This is an explanation that you need to think about. We should know that if it's translated 4 units up, k is positive 4. And by the way, that quiz you just wrote, that's kind of a gimme quiz, I think. If you don't do well on this quiz, then we have a real problem because it covers 2 basic ideas, h and k. Okay. The fact that this function is translated 3 units to the left means that h is negative 3. And I'm going slow in my brain here because it's very easy to get on autopilot and say the wrong thing. Right? You have to think carefully about this. So we know the value of h and k. But let's imagine for a second, and I don't know how you're going to cope with this in your notes. Let's imagine that this is not the question, but this is the question. Let's imagine that I just said a function, y equals f of x. I didn't tell you the equation of the function. I said the function is y equals f of x. What's the equation of the new function? Well, we've already established that h is negative 3, and you can write this down in this question, no doubt about it, even though I've changed it from y equals 1 over x to y equals f of x. We still know that h is negative 3 and that k is positive 4, right? I don't think there's any argument about that. Which means when you use this template, which by the way is on your formula sheet, I don't want to show it to you yet or give you the formula sheet yet because it's on your formula sheet, but there are other things with it. It's not just that, it's got other letters in it. When we use that template, all we do is we put the parameter value of negative 3 in for h and the parameter value of 4 in for k. So the new function is f of x minus negative 3 plus k, which is 4. And I hope you're fine with me saying minus, negative, and just writing plus at the same time. So let's walk away from A here, from question A for a second. We're not done A, because this was not A, was it? It's not A. Let's take a look at B. So B, we have a different function. Y equals the absolute value of x, and it's translated 5 units up and 2 units to the right. Well, let's imagine it said this, which would be a question from yesterday. What's the equation of the function y equals f of x if we translate it 5 units up and 2 units to the right? So, by the way, I don't know why I'm giving the vertical description first, followed by the horizontal. It's just what popped into my head when I typed these out for you, okay? And I usually list them as h and then k, so you've got to be careful if you get into a habit of having them in a certain order in your brain and on paper. It's 5 units up, which means that k is positive 5, and it's 2 units right, which means that h is positive 2. And are we in agreement with the values of those parameters based on the descriptions? Okay, that's yesterday. Well, that would mean, and I'm not going to bother writing down this template this time. It should be very familiar to you. That would mean that the equation of this function is y, this new function, y, or g of x if you want, is f of x minus 2 plus 5. And this is basically would be a quiz question from today's quiz. And I know that it seems like I'm talking down to you right now because this is so simple, but there's a point that we're going to get to in a second that I want to make. If we do the same thing with C, the function is y equals x cubed, and it's translated 6 units down and 1 to the left. Well, if I didn't tell you the equation of the function and I just said a function, you should be able to say that y equals f of x plus 1 minus 6. And I have a question for you. And I asked this yesterday, and I recall the answer in terms of how many people said yes. How many of you don't need to write what h is and what k is to write out the equation of the function? And in fact, how many of you find it not just quicker, but easier? Like you say, it's 1 to the left, it must be x plus 1. You've got that kind of pattern in your head. It's 6 down, so it must be minus 6 at the end. Okay. But for completeness sake, I'm going to write here that h is negative 1 because it's 1 to the left, and when you take x minus negative 1, you get x plus 1. And k is negative 6 because it's 6 units down, so we have plus k, so it's plus negative 6. And we don't walk around saying plus negative 6, we just say minus 6. And to round this out, I don't know if you've noticed, but we have 4 possibilities. You can have right and up, right and down, left and up, left and down, and that's what I've got for these 4 illustrations. What if I had y equals root x and I translated 8 units down and 2 units to the right? Well, again, just play along here for a minute. Let's imagine that it doesn't tell you the specific function. It just says a function. Y equals f of x is translated 8 units down, which means k is negative 8. And 2 units to the right, which means h is positive 2. And again, are we in agreement on that? Okay. Which would mean that the new function is y equals f of x minus 2 minus 8. Good? No problems. Okay. So let's go back to A. A, we developed this. Now, I have to rewrite it. Yours is already written down. We looked at h and k, and we said this must be f of x plus 3 plus 4. Am I right? Okay. So what does this mean? Because it's not just y equals f of x, it's y equals 1 over x. The first thing I want you to do is make a note that y is the same thing as writing f of x. So even though we weren't told the function is f of x equals 1 over x, we were told the original function is y equals 1 over x. We can always say f of x equals 1 over x. And now I want to I'm going to go to a new page for this. You can feel free to just absorb what I'm about to tell you in this mini lesson or write stuff down. I don't know. It's up to you. But if I were to talk about this function, f of x is equal to 1 over x, and I said to you, what is f of 3? I said, what is f of 3? What that means is that when x is 3, I mean, look at the comparison here. F of x, f of 3. The x has changed to 3, hasn't it? I mean, I've changed it intentionally. But what that means is when x is 3, what's this number? But this is y, right? So all f of 3 is asking you, I'm going way back to math 10. All f of 3 is asking you to find is the y coordinate of the function when x is 3. And how do you do that? Well, you write that. And I want you to notice, and this is very simplistic, but maybe it wasn't presented this way in your math 10 class. I want you to notice that every place in the original function that there was an x, that became a 3. So to find f of 3, we replace x in the original function with 3. If I said to you, so we get 1/3. And again, this is such basic math. But more complicated math is built on fundamental basic ideas, okay? If I said to you, what is f of pi? Well, it would be 1 over pi, wouldn't it? Okay, well, that would mean when x is pi, y is 1 over pi. If I said to you, what is f of 3r plus 7, you might kind of shake your head a bit and go, what is he talking about? It's more nuanced than what I'm about to tell you, but most of math in terms of what we write is just squiggles on paper, and those squiggles represent things. And we have a set of rules for how we treat those things or those variables or those numbers or those marks on paper. And if f of 3 is 1 over 3 and f of pi is 1 over pi, then f of 3r plus 7 is 1 over 3r plus 7. The point is, it doesn't matter what is in that function notation. I'll do one last one just to hopefully drive the nail home in case it isn't there yet. If I said, what is f of puppy? Don't overthink what that means. Symbolically in mathematics, that means since f of x is 1 over x, f of puppy is 1 over puppy. And don't try to figure out what the reciprocal of a puppy is. Some kind of unnatural thing. It doesn't matter, okay? Why am I saying this? Well, because the function we've decided on is that it's f of x plus 3 and then plus 4. So what is this? Well, this is the result of putting in x plus 3 for x. And here's where it gets a little bit hard for the brain to cope with. We're going to write that y equals, I'll write it over here, f of x plus 3 plus 4. So that means the new function is y equals 1 over x plus 3 plus 4. And the thing that you probably can have difficulty with, many of you will have difficulty with, is how do I get away with saying x is the same as x plus 3? I'm not saying x is the same as x plus 3. X was what was there on the original function. What's there on the new function is x plus 3. I'm not claiming x equals x plus 3. I'm saying x has been changed to x plus 3. And many of you will not need to use this notation. You will say to yourself, looking at this function, if I shift this function 3 to the left, then this x has to become an x plus 3. Every x in the original function gets replaced by x plus 3 because it's f of x plus 3. In other words, you're always going to replace x with x minus h. And this is the function. This is the answer to the question. Now, I have one last thing. I shouldn't have done that. I have one last thing while I'm waiting for my computer to catch up. Oh, there it is. To discuss with you here. If I gave you this question on an exam and you write this, that's not good enough. Because you're given the specific equation of the function, you can find the specific equation of the transformed function. Are you with me on what I'm telling you? Because your textbook doesn't always do that. Your textbook sometimes will give you this question or a question like this and end it here with what the green arrow is pointing at. And that's not good enough. You have to be able to find the specific function. So over here in B, we had, I believe we had y equals f of x minus 2 plus 5. Am I right? And I'm just getting that by reading the question again. But f of x is the absolute value of x, which means f of x minus 2 is the absolute value of x minus 2. You with me? Okay. With C, we said that the new function y equals f of x plus 1 minus 6. Again, to keep you on your toes and to make sure I didn't make a silly mistake, is that what we agreed on? Okay, 1 to the left and 6 down. But f of x is x cubed. So f of a pizza would be whatever the cube of a pizza is. F of x plus 1 would be x plus 1 cubed. And I suspect many of you would have been able to come up with these answers without my explanation. But that explanation is needed for some further things we're going to deal with in the coming days in this class. And D, we said that since it was shifted 2 to the right, h was positive 2, so x minus h is x minus 2. And since it shifted 8 down, k was negative 8. But f of x equals root x, which means f of x minus 2 is root x minus 2. I like to put this little kind of hanging overhang there on the root sign to indicate that's where it ends, because sometimes in type it's not that clear. So that would be the function. Now we're not done with this because there are some other nuances I want to talk about here. First of all, and I think this is fairly obvious, but we will just make sure, this answer that I have here could be written as that, couldn't it? I mean, rather, and that's really a nice way to put it, because then when you take a look at that, which is the transformed function, and you look at the original function, we can definitely tell which one is which. We have labels for them. One is called f of x, one is called g of x. Okay. We could do the same thing here. I could put g of x equals absolute value of x minus 2 plus 5. I could put, I don't know, I could put r of x equals x plus 1 quantity cubed minus 6, etc. Are you with me on that? Okay. Now, I want to talk to you about something, and if you had me for Math 20-1, you might remember this, but I really need to just take another minute or two and give you another mini lesson on some terminology. When you talk about, I'm going to start with a different one. When you talk about this function, okay, and when we're talking either about this one or this one, the argument, is there an E after the U in the word argument? math major here? I don't think there is there? Does it seem like there should be? Anyone? My kind of crowd. Nobody knows. That doesn't look right. No. Okay. The argument on x is a square root. Okay. So when we look at either of those functions and I say, what's the argument? The argument is a square root. I know that doesn't sound right, but that's the terminology we use. The argument is the main operation that is occurring in the function. Seamus, you're sitting over there, please. The argument is the main operation that's occurring in the function. That's okay. Thank you, Maddie. So when I take a look at D and I say, what is the argument? The argument is the square root. If we go back to C, I believe C had the cubed. Yeah. What is the argument in this function? Whether it's the original or the transformed, the argument is cubing. It's what's happening operationally to the thing that contains X. The argument here is an absolute value. Are you with me? I started back there because talking about the argument for A is a little bit awkward. The argument is the reciprocal. It's 1 over. So now I have a question for you, and it lies at the heart of this whole function notation. When I take a look at, say, this, I'm going to pick on C. These are both correct. Would you agree? But one is more correct. The bottom one is a better answer. It's more complete. The question is, and I never really thought about this until a student asked me one time, they put up their hand, they said, oh, you made a mistake. And I looked at it, I said, where? They said, you forgot to put a cubed up here. I forgot to put a cubed on the x plus 1 in the first line. And this was a long time ago. And I had to think about it for a second and realized, no, that's not right. And I had to explain to the students. Similarly, with this one, people say, well, you're missing an absolute value notation there around the x plus x minus 2. No, I'm not. You forgot to write 1 over here. No, I didn't. There is no 1 over there. And I'm going to finally go to the last one to illustrate this. And I hope some of you understand what's going on here. Why do I not, it's not even a matter of not needing to. Why don't I put a square root over this x minus 2? It's a good question. I'll give you a hint. It's there already. Does anybody have a solution to this little conundrum? Yeah. That's true. It's f of x. So really what we're talking about here is this. When you look at the original function, f of is the argument that's the square root. What this means, and we would never write this, this is not valid notation, but the function, what's happening to x, is a square root. So when we write this here, this is the same as that. They mean the same thing. It's just that you have to know what this is in order to understand that, right? And if you don't know what that is, then you stop at the function notation, but we do know what it is, so we include the square root. All right, so we have a couple more examples to do. Number 2, now we're delving some of these questions you saw in the quiz and some of the questions we have been working on could be on exams and diploma exams, but you're not going to get a whole boatload of those questions on an exam. And you might get just one or two, just a little sprinkle of them, and then some more complicated things. This is a good exam question. What vertical translation is applied to y equals x squared if the transformed graph passes through 5, 12? First of all, forget about everything you know about y equals x squared. I could come up with any function. I could say to you, what vertical translation is applied to this, which you don't even know what it looks like. What vertical translation is applied to that so it passes through 5, 12? I could say what vertical translation is applied to tan squared of x, whatever that means, and you don't know what it means yet, but it doesn't matter. You could still solve this problem. And the point I want to make here is you are not going to solve problems like this by graphing y equals x squared and trying to figure out how to move it so it passes through that point. You're not going to solve it like a puzzle. It doesn't work that way. Because if you do, then you're going to have hundreds of different puzzles that would have hundreds of different approaches. I'm going to teach you the one approach that will always work. If you were asked to find what vertical translation, what you were really asked is what is k equal to? Would you agree? Okay. So I'm going to use the same terminology over and over again in the hopes that it sticks. This is a missing parameter that we are trying to find. That's why I've been using the word parameter for h and k. And to find a missing parameter, which may have something to do with transformations, or it may not. Remember, a missing parameter is just a number in a function. So if I said to you, y equals ax squared plus 3x minus 2, this is a missing parameter. This a is a missing parameter. And if I told you that this function passes through a point, I'm going to write this down, passes through, I don't know, 1, 8. What is a? We're going to come back to that. This question here, which is actually a Math 20 question, fundamentally is the exact same idea as this question. It is. Except you don't have the equation with the parameter in it until you do this. Now we got it. Right? K is the missing parameter for a vertical translation. It's something that's added to the original function to get the new function. And I want you to notice here that this question contains now a function with a missing parameter. It contains a point that the function passes through, and it's asking you to find that parameter. Yes? This made-up question has a function with a missing parameter. It tells you a point that it passes through, and it says, what's the parameter? They're the same question. So I have a question for you. Does anybody know how we can find k? Okay?
Put in the values of the point for x and y.
Right. Now I'm going to ask you a question. Do you remember that? Because we did similar stuff in 20-1. And it's hopefully that missing parameter. There's always the same strategy. Missing parameter, load in numbers for x and y and solve for that missing parameter. But you can't just, throw darts at a board and pick numbers for x and y. They have to be numbers that go together. This is saying, in this function, 5, 12, is saying, here's the function, and we're going to use this idea a lot later on in the course, that when x equals 5 goes in, what comes out? Y equals 12. That's what it's saying. It's saying when x is 5, y is 12. And that means we can take this highlighted function and simply say 12 equals 5 squared plus k. I certainly don't need brackets around the 5, but I like whenever I do substitution to put a set of brackets around something because sometimes it's important. It's not always, but if I put them there all the time, I won't make any mistakes, or I'll make fewer mistakes. So we simplify this. This is 12 equals 25 plus k. We have gone from, now I realize I didn't teach all of you Math 20, and your Math 20 teachers may have taught things differently, but we have gone from at the top of the page here, a Math 30-1 question, to a Math 20-1 question, to an elementary school question, assuming, I don't know when they teach negatives. It's got to be by grade 6, I would think. So what number do you add to 25 to get 12? Well, we have a formal way of solving that by subtracting 25 from both sides, and unless I'm mistaken, k is negative 13. Okay. So the answer to this question is 13 units downwards. And I could certainly verify that on my calculator by graphing y equals x squared minus 13, and you just have to get used to the fact that that's how I enter x squared sometimes. And I'll enter x cubed by going xxx. Okay. And it has to pass through 5, 12. Is that right? So I'm going to adjust my window settings. Well, I'm going to go zoom standard first, which goes from -10 to 10, -10 to 10. It's not going up to 12. I want to see that point. So I'm going to go to my window settings and go up to, I don't know, 15. While I'm at it, I might as well bring the vertex into view. I think that's good enough. So there's the function. If I go trace 5, success. Okay. And again, I know that some students would want to look at the graph and get some graph paper and go, how can I shift this thing up so it passes through that point? There's a tried and true method. A missing parameter is found by replacing x and y with an ordered pair and solving for the missing parameter. So when we look at example 3, am I going too fast this morning? Too slow? Goldilocks, just right. Okay. What horizontal translation? Well, that's saying determine the value of h, right? Because a horizontal translation is related to the parameter h. Now, in today's assignment, you're going to have a textbook question that has a horizontal and a vertical translation, both happening. And I won't reveal to you exactly what you're going to do there. I'm going to want you to try it first. But the bottom line is, this is going to become y equals f of x minus h. I'm introducing the function notation here. The function was x squared, which means the new function is y equals x minus h squared, because that f means squared. It passes through 10, 9, which means that when x is 10, y is 9. Now, well, if you've had me as a math teacher, you know this. I'm going to take a couple opportunities here to review some basic math that's important here. I don't want to just go through and solve the problem. There's other details that are going to be helpful for later. This means that when I replace x with 10, I have to get a y value of 9, and this is what I want to solve. So how do you solve this? Well, let me show you one way to solve it that includes a mistake. Okay. And then we'll talk about what that mistake is. Since this is squared, if I want to get at the h, I have to get rid of that squared, and that involves taking the square root. And that works out nice because 9 is a perfect square. So if I take the square root of both sides, what I get is 3 equals 10 minus h. And again, I haven't taught all of you math. When I'm trying to solve what's called a linear equation, because it's the variable is to the 1, the parameter is to the 1. When I'm trying to solve these types of equations, I always arrange it so that that term that has the unknown is positive. I don't like having negative unknowns. So what I do is I move the h to the other side. That's what I say. I'm going to move it to the other side. I've really added h to both sides. And I'm going to kick that 3 out of the way. And the bottom line is what I'm doing here is called transposition. When you have a term on one side of an equation and you move it to the other, it switches signs. If it's positive on one side, when you move it to the other side, it becomes negative. If it's negative on one side, it becomes positive. So we end up with h equals 7. I am just curious at this point in time, how many of you see the mistake I've made? I'm not asking you for it, but I'm asking you if you've seen a mistake that I've made. And I would be surprised if anybody does, but I wouldn't be overly surprised if somebody does. Okay, we'll come back to that. So, that's what Peppermint Patty does. What Charlie Brown does, Charlie Brown's a more literal thinker because his math teacher has said when you have an equation, you should simplify the equation. And he's remembered simplify means multiply things out. And when you square 10 plus h, you get 100 minus 10h minus 10h plus h squared. So here's a first little tiny mini lesson. That's what you get when you square 10 minus h quantity squared. You do not get something like that or something like that. I kind of say jokingly, every time a student does this, a kitten dies. Okay? So stop doing that. Think of the kittens. How am I getting, can somebody offer up an explanation for what I'm doing here to get this beast at the bottom? What's happening? Lynette? Right. And I don't have a problem. I mean, I know I used to be the kind of teacher that would say, oh man, you should know that. And then I've learned it only takes a second for you to write that out. And if you have to write it out to see that we have to FOIL things out to do it, then do it. Okay? But we don't want to make that mistake. There's some bigger fish to fry in this lesson, though, in this little mini lesson. When I simplify this, I look at it first of all and I go, you know what? This is quadratic. And in Math 20-1, I learned that quadratic equations are solved by always zeroing them, unless you want to complete the square, which I don't think anybody wants to solve an equation by completing the square because most people wouldn't even remember how that works. And it's a real pain. So we zero this, and I have a positive h squared on the right-hand side. So I'm going to leave it there. I have negative 20h. And then I have 100 minus 9, which gives me 91. And this is equal to 0. And there's an awful lot I'm trying to pack into this one question that's not about Math 30. Is this factorable? Well, are there two numbers that multiply to give 91 and add to give negative 20? I think 13 and 7. Can you verify that 13 times 7? It's plus 21, isn't it? Or plus 91. Can you verify that 13 times 7 gives you 91? It's kind of a difficult one to do, but we'll talk in a minute about another way you could solve this. So this factors into, and we're going to be dealing with a lot of factoring later in the course, x minus 7, or h minus 7 and h minus 13. And the only way that a product, there's a multiplication sign in here, the only way that the product of two things can give you 0 is if one of them is 0 or the other one is 0. So this is where we get the idea of this. Which means h equals 7, add 7 to both sides, h equals 13. Now we've got a serious disconnect here between what Peppermint Patty did and what Charlie Brown did. Because Peppermint Patty got one answer and Charlie Brown got 2. Charlie's right. And by the way, we'll look at the graphs in a second. The reason why you can shift at 7 or 13 is because the parabola has two arms. And here's that point it has to pass through. The tip of my nose is the point it has to pass through. When I shift at 7, it passes through that point. When I shift at 13, it passes through that point. The algebra doesn't lie. It's going to work. So now I'll ask again, what did Peppermint Patty do wrong? Maddie? Pardon me? That's not where we handle that. And it turns out if you go 10 plus h and 10 minus h, that doesn't quite work, but we're on to something. Can you tell me, if I gave you x squared equals 9, I better not do that. Yeah, sure, why not? If x squared equals 9, can you tell me the value of x? What's x equal to? 3? Is 3 the only number that you square to get 9? Negative 3 squared also gives you 9. Negative 3 quantity squared gives you 9. What Peppermint Patty forgot to do is remember that when you introduce a square root, you have to go plus or minus. That was something new last year in Math 20. And that means that what she should have gotten is positive 3 equals 10 minus h, and negative 3 equals 10 minus h. And if you solve this equation, you move the h over and subtract the 3. If you solve this equation, you move the h over and add the 3. And I think that's what you were getting at, right? But I want to really point out that the solution to this lies in you putting plus or minus whenever you take the square root. And if you forget to do that, then you get half of the answer. So the answer to the question is there's two solutions, 7 units to the right or 13 units to the right. And again, just like I said yesterday, you don't, on a written response, want to abbreviate your answers like that. You would write out a more complete statement. Just to show this to you, what does it have to pass through? 10, 9? Okay. So there's the point, 10, 9. I'll adjust my window settings a bit here, 15. There's the point, 10, 9. I just put it in my stats list. One of the functions, if h was positive 7, the function would be brackets x minus 7 n brackets squared. Let's just check it out. Passes through that point. We could verify it by going trace and entering 10, seeing it passes through 9. And here's the other one, x minus 13, quantity squared, will also pass through that point. And I guess just to finish this off, tie a bow on it, this whole missing parameter thing, if you solve it with that basic idea that you need to load in an x and a y pair that go together, as I said, the algebra doesn't lie. It doesn't become a guessing game or some kind of puzzle you're trying to crack. You know, there's a method to it, and if you follow the method, you'll get it. It's like, see those geniuses solving Rubik's Cube in like 5 seconds? They're not just randomly trying stuff. They look at the colors and they have a set of rules that they follow. All right, so I will have those quizzes marked and maybe even back to you by the end of the class, but I'll definitely have them marked and back to you by tomorrow, but maybe by the end of the class. Here are the questions from today's lesson. For number 17, you're going to have 2 missing parameters. And the hint I would give you for number 17, I'm giving you a hint that says the zeros are 7 and 1. Those are x-intercepts. So the graph passes through 1 on the x-axis and 7 on the x-axis, which means you have two pairs of points. Do you have 2 points? And if there is a horizontal and a vertical translation, then this is your problem. What's H and what's K? And I'll leave it at that. We will definitely be going over this question tomorrow.